8.1, natural magnetism and electromagnetism. So what is the magnet? You might have seen a magnet that has north and south pole in magnet. So here is the field around this magnet depicted. As you see, this is like a circle, it's just going from north to south. Like a closed, is in a loop here. As you see, closer to the magnet, these lines are very intense compared to a further distance, which is less intense. So it means closer to the magnet, it will exert a stronger force. We know about the Earth's magnetic field. It would be the same thing as a magnet here. Because of the core of the Earth, there is a molten metal on it, so it will actually produce a magnetic field. And you know, if you have a if you have metal, it will produce, so these electrons will align along the magnetic field, right? So here's the principle of electromagnet. Moving electric charge produces a magnetic field. If an electron is moving, it will produce magnetic field, right? This principle applies that if you have a conductor, like a wire, the electron is moving, right? Make sure when you're talking about a wire with the current inside, conveniently, we say that the positive charge is moving, okay? So here, the charge is moving inside this wire, so it produces magnetic field. Now, what is the direction of the magnetic field? I'm gonna just give you a demonstration here. Let's say this is my wire. You use your right hand. Why right hand? Because we're assuming is positive charge is moving for conveniently. You put your thumb in a direction of the current, then your forefinger bend toward magnetic field direction. It's gonna be into here. If you do that, it's gonna be into my face, right? Just like that. My forefinger going to my face. The same thing here. If I put that here, it will produce magnetic field, which if I try that again, it's like that, right? Back of this, back of that is going up, and in front is go down. So again, thumb in direction of the current, in front of the wire, the magnetic field go up, and back of the wire, magnetic field go down. Okay, so here is up, and in front of the wire, it's just like a loop, right? And now let's see if the direction of the current is in reverse direction, what happened? Now the direction of current is here. Now my thumb gonna be in the direction of the current. At the back of the wire, the field go up, and in front of that, field go down. So just move your finger like a circle around that. In front go down, backward your finger go up, right? So here again, I put a loop. On the back, it go up in front, and in front of that. Here it is. Front of that, go up. You can try that and practice the direction of this magnetic field. So you can see that there. So your thumb in the direction of the current and your forefinger being toward the direction of the magnetic field. The same thing, if you want to do that, so at each section, as you just try to do it at this section of this loop, this direction, you just imagine you put your finger in the direction of the current and you see your forefinger bending toward the direction of the magnetic field. I can imagine that for last section, for all of the sections, you can do that. As they demonstrated here. Magnetic field of a coil. Now we have a coil. Here is the thing. Inside the coil, we have a uniform magnetic field, and outside the coil, it's kind of a loop. Now, how we determine the direction of the magnetic field inside the coil? Okay, how? Here is how. Looking at the current going up in front of the coil, right? According to this. So imagine it's coil. I know it's like a wire, but here is a coil. The current going up. So you put your forefinger in a direction that the current is moving. In front of the coil is move up and back of the coil is go down. So your thumb will be in a direction of the magnetic field. So as you see here is the direction of the magnetic field. As always, your thumb is pointing into the north. Okay, and here is the south. So it's gonna be, for outside is from north to south, for inside is south to north. So we call it solenoid, right hand rule for solenoid.